In today's session, we'll discuss about remaining operators. So, what are those? Python logical operators. So, these operators are used to check whether an expression true or false. Again, these are used in decision making. For example, x is equal to 100, y is equal to 200. Print x greater than 90 and y greater than equal to 200. This is an example. It results what? See here, x value is 100, 100 greater than 90, true, and y greater than or equal to 200. Here equal to is there. This is also true. True and true, true. So basically, and logic is these are like terminology related to electronics and digital fundamentals. So basically, if we have two inputs, hash 1 first input, hash 2 second input. Here let us say the first input is 0, second is input 0. Again another scenario, first input is 0, second input is 1. In another scenario, first input is 1, another input is 0. In the last scenario, we have four combinations. First input is 1 and second input also 1. Here what is the result? So in this case, first input, second input, ANDing. So we are multiplying basically 0 dot 0 into 0, 0. Here 0, 1, 0 into 1, 0. Here 1 into 0, 0. 1 into 1, 1. So likewise, if you see the first one, print statement, x greater than 90, 100 greater than 90. So it is true. True means basically it values equal to 1 and y greater than or equal to 200, y value 200, 200 greater than or equal to 200. 200 is not greater than 200 but it is equivalent to 200. This is also true. True again, it values 1. So 1 and 1 equal to 1 only. This scenario. So that's how the calculation happens. Now if you see operator example, logical and, so operator and example x and y. So if we observe this table, it is a kind of table with four combination. So first input is true, second input is true, then only the result will be true. So what it means? True if both the inputs are true. That's how it works. Then OR combination. What is, again if you think about OR, so we'll discuss about OR logic. We'll take the same set, but here result is OR means basically addition. So the result here changes. We'll discuss. First input is 0, second input is 0. So if you add these two, 0 will come. Second, any one input is high, the result will be 1. 0 plus 1, 1. 1 plus 0, again 1. Here in digital fundamentals, the last combination, first input 1 and second input 1 plus 1. Here also the value is 1. Like that OR logic. And OR here, if you see any one input is high, then the result is high, x or y. So if any one of the input is high, then not. Here basically what happens, this is a logical not. The second one is logical or third one is logical not. Here in this case, it will become true if the operand is false and vice versa. Means, for example, let us say print not true. That means false for last one, not. So these about this information about logical operators. So these are useful in decision making. For example, if you wanted to test these things, we'll take this one and we'll check what it will print. Python. Save in one file and we'll save. Go here, directory, check where it is, the file, this one, CLS, Python, execute. So it has to print true, correct only. So what we understood, the exactly same it is getting printed true. Now we'll discuss about Python bitwise operators. So these operators have something special. These operators act on operands as if they were strings of binary digits. They operate bit by bit. So what does it mean? We'll take one example. First of all, when you what is like binary digits? Uh, Basically, let us say one number is there, 0. This is, or else we'll take 1. So here, if you want to write this number into binary, we'll have to write, let us say 4-digit number in binary. It is equivalent to 0, 0, 1 like this. Let us say 2, 0, 0, 1, 0. How it will be calculated? Let me explain. First of all, 0, 0, 0, 1. If you take, I'll give space. This is a binary. We'll convert into decimal. Decimal means this value, this value. So here, the first one is binary, means binary is in the base form of 2. Binary is in the base form of 2. Decimal is in the base form of 10. So you might have known all these things, but just recapping. Here, if you take, this is a binary form. We'll convert it to decimal form. How to convert? I'll tell. This is binary form is there. So binary, what is the base? 2. So first digit represents 2 power 0. First one. So this is the one. Then if you talk about 2 power 0, else one thing I'll do, it is cap 2 power 0. Let us search this one 2 power 0. Okay. Here 2 power 1. The second case 2 power 2. Here 2 power 3. Like this. So what we need to do now, if you try to convert, the first one is 2 power 0. Any power 0 equal to 1 only. The value is equal to 1. So here 1 star 1 put in bracket plus this one is 2 power 1. So that means 0 star 2 put in bracket. This one 0 star 2 square means 4. This put it in bracket. This one 0 star 2 cubed 8. So all you need to add. So plus likewise. So if we add it, what is the value? 0 star 8, 0 plus 0 into 4, so 0 only, plus 0 into 2, 0 only, plus 1 into 1, 1. So if we add all these, the value is equal to 1. So that's how the representation from binary to decimal. Okay, so we have proved. So 0, 0, 0, 1 equal to 1. This is the one we have proved it. So this is the way we need to do. Okay. So in by understanding this, we can write 3. If you convert the 3, again how to convert 3 to 3 is a decimal. So to binary, how to convert? Let me explain this. 3, 1 second. So take 2, 2 1 ja 2. So what is the remainder? 1. So here you need to uh, this one first we need to take up the remainder one. So now everything is completed because 1 1 only, we cannot further do conversion. So first we need to take the remainder, then followed by previous so 1 1. So this we can also write in 0 0 1 1. So that is equal to 3. So here 3 0 0 1 1, like that you can convert. Likewise, if you calculate 4 is equal to 0 1 0 0, 5 equal to 0 1 0 1. This is the conversion, like decimal to binary, binary to decimal. If you haven't known, you just check any documentation how to convert to binary to decimal, decimal to binary. Okay. Now, so now if you create uh, we'll try to see one example here. Let us take a equal to 10. This is a decimal. In binary, how we need to write 0 0 0 0 1 0 1 0. This is a binary value. And b equal to 4. This is the for 4 decimal binary value 0 0 0 1 0 0. So now if you prepare table kind of operator, meaning example. So bitwise and this is the symbol. We call it as bitwise and. Now a bitwise and b will become so if you bitwise and means bit by bit we need to multiply. So first bit for 10 0. For 4 first bit 0 0 into 0 0. Likewise, you if you do this particular AND logic, this is the AND logic, then you will get the this is the AND logic between first input and second input. So if you get you will get the result 0 0 0, all zeros only. Then bitwise OR, bitwise OR A B. Again you need to implement bitwise OR logic means we will get it 0 1 0 like that. Then not symbol is this one, bitwise not, let us say minus a here equal to you need to invert the bits. A bitwise not means whatever, for example a value 10, for 10 these are the binary representation 0 0 0 0 1 0 1 0. So each and every bit we need to complement, invert it. So it will become 1 1 1 1, 1 will become 0 0 1, it will become 1 1 become 0 0 become 1 like this. Then exclusive or, exclusive or, what is the symbol for exclusive or? These are all digital gates. X bitwise XOR. What is the logic? Bitwise exclusive. I'll copy this XOR. So if you, this result will get changed. What is the logic here? If both the inputs are same, result will be 0. If any one input is high, will become high. Here also one input is high, so that become, and last one both inputs are high, it will become 0. This is the OR logic, exclusive OR. So if you perform this for bitwise exclusive OR for A cap B equal, it will become 0 0 0 triple 1 0. This is the logic, the one which I explained. Then right shift, bitwise right shift. Let's take A, for A value right shift. So two values, two digits we need to right shift. So it will become A is equal to 10. This is the value. On this value we need to do right shift for 2 bits. So it will become 0 0 0 0 1 0. Likewise left shift on one value again. Left shift means two left side operator. It will become, it will become 0 0 1 0 1 0 0. So likewise, that's all for today class. Still some more operators are left. We'll discuss in next session.